Corollary 27.1 says this: 2 points, each equidistant from the ends of a line, determine the perpendicular bisector of that line. We know that 2 points determine a straight line. Only one straight line can be drawn through 2 points. And so we're saying that 2 points, any 2 points, they could be above the line. Any 2 points, each equidistant from the ends of a line, determine the perpendicular bisector. So P is equidistant from the ends of this line, and Q is also equidistant. We're not saying that P and Q are the same distance away from the line, or even the same distance from the same end. We're just stating that P is equidistant from that the 2 ends. P is also equally distant from the ends of this given line. So we're given segment AB with points P and Q each equidistant from A and B, And we're trying to prove that PQ, if we were to draw a line between P and Q, it would be the perpendicular bisector of AB. So let's quickly draw some auxiliary lines. We're going to draw, number 2, draw PA, PB, QA, and QB. 2 points determine a straight line. Number 3, I can, let's draw those. If I were to draw PA, if I were to draw QA, QB, and PB, we can now state that PA, oh my goodness, let's zoom in, PA equals PB, and QA equals QB. Well, we're told that these points were equidistant from the end of this given line. And so that's just the definition of being equidistant. They would be equal to each other. So we could say definition of equidistant. Equidistant. There we go. Number 4, I'm going to say that the triangles APB and AQB are isosceles triangles. So here we go. I just stated that these are isosceles triangles because obviously they have equal legs of the triangle. And so there we go. Piece of cake. Let's draw an auxiliary line again. Let's draw another one. Draw PQ. Let's draw that real quick. Connect P and Q. And I hope we remember, I never gave the reason here. Number 4, reason that they're isosceles, definition of isosceles triangle, Number 5, I can say 2 points. Determine a straight line. And obviously, if you know in advance what your proof is looking like, or I could have done this. I could have just added draw PQ. I could have just moved PQ right on up to here because they both have the same reason. So if you want to save yourself writing, feel free to do that. So now we have our line that is potentially our perpendicular bisector, and honestly, we can say that PQ is the perpendicular bisector of AB. And I have posted a video on why, and we proved that if 2 isosceles triangles have a common base, the line that joins the vertex, the line that joins the vertices bisects the vertex angles and is also the perpendicular bisector of the common base. We used a triangle that kind of looked like this. This was an isosceles triangle. Let's make it a little bit better. And we had another isosceles triangle on the inside, and then we had a line that went right on through both of them. And I'm just doing this for sake of example. And when they went through both of them, we saw that that this line bisected both of these vertex angles, and it was perpendicular also to the base, and that it also bisected the base. And so we prove that with that kind of problem. And so whenever we come across something like that, this is a little bit different, but they do share a common base still. If we were to kind of just flip this triangle over on its side, it would kind of be the same idea. And so it doesn't have to be that same example. If they share a common base, the line that joins the vertices of those isosceles triangles bisects these two vertex angles here, and it is perpendicular. It is the perpendicular bisector of the common base. Test.